Hi everyone, welcome to another module of Accelerated Computing video series. In this module, we are going to cover AWS AI ML hardware accelerators, which are AWS Trainium and also AWS Inferentia. We are going to cover the architecture, the key components, and also the key feature that actually just set them apart from the rest of these accelerators ecosystem. We are also going to cover the integration in AWS and also AIML ecosystem. So if you're ready to explore, let's dive in. So the application of AI are becoming increasingly sophisticated. So from personal assistant that understand our command to self-service or self-driving car that navigate complex environment. This progress is driven by the development of complex AI/ML model, things like large language model. However, these advancements come with a challenge. These models require enormous computational resources, far exceeding the capabilities of the traditional hardware, like the ones which are based on CPU. Training these models can take days or even weeks, leading to delay in innovation and also higher cost. In addition, deploying this model for real-time applications, such as responding to user queries or making predictions on live data, requires significant processing power to ensure low latency and also a smooth user experience. To overcome these challenges, AI/ML accelerators have emerged as a game changer. These accelerators especially are designed for AI workloads, provide the computational horsepower and also efficiency needed to train and run complex model effectively. There are three main types of hardware accelerator commonly used. So the first one is the GPUs, which are highly parallel processing, which initially they were designed to handle the complex calculations required for graphic renderings. However, their parallel processing capabilities have made them highly adaptable for AI/ML workloads where large amounts of data need to be processed simultaneously. The next type of AI/ML accelerators were the FPGA, which offer a unique advantage. So unlike GPUs or CPUs, these hardwares and the hardware logic within FPGA can be reprogrammed to tailor the chip to a specific AI/ML algorithms. This allows for greater flexibility and also potentially higher efficiency for a specific task. The third type of AI/ML accelerators are ASICs ones, which take specialization to the next level. These chips are custom designed for a specific AI workload, such as image recognition or natural language processing. AWS Trainium and also Inferentia are prime example of ASICs tailored for AI/ML tasks. Their architecture is optimized to maximize performance and efficiency for the intended purpose. Now let's go through the journey of these hardware accelerators. So the story of AWS AI/ML hardware accelerators began with Annapurna Labs. So these innovative company founded in 2011 was driven by a mission to modernize chip design. The initial focus was on developing high-performance, energy-efficient chips for data centers. When AWS acquired Annapurna Labs in 2015, it marked a pivotal moment in the evolution of AI/ML acceleration. AWS recognized that the immense potential of Annapurna Labs' expertise in chip design coupled with the demand for AI/ML capabilities. Their effort led to creation of AWS Inferentia and Trainium. So in 2019, AWS introduced Inferentia, which was in September 2019. The first generation of Inferentia chip was designed to accelerate ML inference workloads. So it powers Amazon EC2 Inf2 instances, delivering up to 2.3 times higher throughput and also up to 70% lower cost per inference compared to the comparable EC2 instances. In April 2023, AWS launched Inferentia 2, which offers up to 4 times higher throughput and also up to 10 times lower latency than its version 1. It supports complex models, including large language model and also vision transformers, and also power EC2 Inf2 instances optimized for large-scale inference tasks. In terms of AWS Trainium series, so the first generation of these Trainium chip became generally available in October 2022. It is purpose-built for higher performance deep learning training, offering up to 50% lower training costs compared to similar EC2 instances. Trainium power EC2 Trn1 instances, supporting a wide range of data type and also integrating with popular ML frameworks through the AWS Neuron SDKs that we are going to cover those soon. Also, Trainium 2 was announced and become generally available just in November 2024. So Trainium 2 delivers up to 4 times the performance of the first generation. It powers EC2 Trn2 instances and also Trn2 Ultra servers designed for training and deploying models with hundreds of billions to over 1 trillion parameters. Trainium 2 offers 3 to 40% better price performance than current GPU-based instances, positioning AWS as a competitive alternative in the AI chip market. So the design of AWS Trainium and Inferentia reflect a deep understanding of AI/ML workloads and a commitment to delivering practical solutions for real-world challenges. These chips are not merely powerful processors, they are also engineered to address a specific need within the AI/ML workflows. So the very first things about the design philosophy of these key innovations is around the specialization. So AWS recognized that a one-size-fits-all approach to AI/ML acceleration would be suboptimal. Trainium and Inferentia embody the principle of workload-specific optimization. Trainium is designed to handle the heavy lifting of training, where massive amounts of data are processed to teach models how to make accurate predictions. On the other hand, Inferentia shines in the inference stage, where trained models are deployed to generate prediction on new data, often in real-time scenarios demanding low latency. Also, another design philosophy for these innovation is performance must be affordable. In the world of AI/ML, high performance is essential, but it comes at a cost. AWS made a conscious decision to make Trainium and Inferentia both powerful and also cost-effective. This philosophy is evident in the architecture. The chips are optimized to maximize the performance of a specific AI/ML operation, using resources efficiently to reduce unnecessarily overhead and also power consumption. Also, AI/ML models and datasets are growing rapidly. To address this, Trainium and Inferentia are built with the scalability in mind. These chips are designed to be interconnected into large clusters, creating a unified compute resource capable of handling massive amounts of data and training complex models that would be impossible on individual chips. In addition, not all data is created equal, especially in the world of AI/ML. Trainium incorporates specific data types such as bitfloat 16, which have been shown to improve the speed and stability of the training certain types of model. AWS also understands that the ease of use is crucial for the widespread adoption of these technologies. The Neuron SDK play a vital role in making Trainium and Inferentia accessible to a broad audience of developers. This SDK provides the necessary tools and also libraries to compile and run AI/ML model developed using popular frameworks such as PyTorch and TensorFlow on these custom chips. This seamless integration minimizes the effort required for developers to leverage the power of Trainium and Inferentia, allowing them to focus on building and deploying their AI/ML solution. To better understand both Trainium and Inferentia, the very first things that we need to understand very well is the NeuronCore. The NeuronCore architecture has evolved across 3 generations, V1, V2, and V3, each designed to enhance the performance, flexibility, and also efficiency of machine learning workloads. So these NeuronCore are actually the processing unit within both Trainium and Inferentia. So let's quickly walk through the advancement from NeuronCore version 1, which was the very first, which was actually released by the first generation of Inferentia chip 2 to NeuronCore version 3, which is going to power Trainium 2 chips. So in terms of NeuronCore version 1, which was the foundation, these kind of like processing unit, as you can see here, it got three key engines. So we got these tensor engine, which are for matrix operation, and also it got the vector engine, which is handle multi-element computation, things like layer normalization and pooling, which are, as if you are familiar with deep learning, you are quite familiar with these types of computation. And also the third types of processing engine, which is the Scholar one, which is more like for design for a Scholar operation, things like activation function, like sigmod, relo, and all those activation functions. The second version, as you can see, got the kind of like similar things. And also one thing that I forgot to mention is this on-chip SRAM memory, which is there to provide more like a kind of the locality, data locality for these processing units. In NeuronCore version 2, plus all those improvements that happen in terms of like the performance, like as an example, the Scholar engine became nearly 3x faster compared to version 1. Or even vector engine deliver a 10x speed up over version 1. And even like tensor engine becomes 6x faster compared to the version 1. And then this new kind of like GP SIMD engine was also introduced, which was more like for developing custom operation. So that was like the key difference between NeuronCore version 2 and NeuronCore version 1. And then the last but not least is the NeuronCore version 3, which, as you can see, kind of like it got the similar architecture compared to NeuronCore version 2, but for sure there are like a number of performance improvement across all these different engines. Also, this memory, on-chip memory, also expanded to 28 megabyte, significantly improved the data locality and also prefetching for large model. So these are like the key, the architecture of those NeuronCore, which, as I mentioned, it's going to be the foundation of those AWS Trainium and French. So now let's go through these Trainium instances. So AWS Trainium 1 or TRN instances were firstly announced at AWS reInvent 2021 and became generally available in October 2022. So TRN1 instances was designed specifically for machine learning training, offering competitive performance compared to GPU-based instances while being more also cost-effective. The second generation, or TRN2, became generally available in just November 2024 in reInvent, just this month. Last one. TRN2 instances are powered by the new Trainium 2 chips, which feature NeuronCore cores, which include like 8 NeuronCores, which I'm going to cover in the following part. And also TRN2 instances significantly enhance memory capacity, offering 96 gigabyte of memory per accelerator, resulting in a total of 1.5 terabyte across a server with 16 accelerators. Also, there was like some improvement in Neuron Link, which is more like a kind of the communication between different types of kind of like Trainium chips. And also, building upon these capabilities of TRN2, AWS announced the preview of TRN2 Ultra cluster in late 2024 as well. So these Ultra clusters take scalability to the next level by connecting up to 64 Trainium accelerator within a single compute domain. And then the last but not least are the Trainium 3, which was just kind of like become in preview in reInvent 2024, which is the next generation of AI chips, which allow customers to build bigger model faster and deliver superior real-time performance. Trainium 3 powered Ultra servers are also expected to be 4 times more performant than TRN2 Ultra servers. The first Trainium 3 based instances is expected to become available in late 2025. So that's the kind of like the journey and evolution of the Trainium based instances. So in terms of architecture, as you can see, Um, in both Trainium and Trainium 2, like in Trainium, as you can see, it actually have like 2 NeuronCore each Trainium chip, while each Trainium 2 chip include 8 NeuronCore version 3 even. Like these Trainium version 1 includes just 2 NeuronCore version 2, while Trainium 2 include 8 of those. And also in terms of like the communication, so there are like some other component within each of these. So we got these high bandwidth memory as well as part of each of those chip, and also neuron link, which is more like for a communication between different chips, which is available. So as you can see, the Trainium were powered by Neuron Link version 2, while Trainium 2 were powered by Neuron Link version 3. So there is a comparison that is there here, which is more around like the comparison of these two instances. So as you can see, Trainium 1 includes 2 NeuronCore version 2 as we showed in the architecture, while Trainium 2 includes 8 NeuronCore version 3. In terms of like the device memory, as you can see, the device memory available on Trainium 2 is triple compared to Trainium 1. And also the bandwidth for Trainium 2 is 2.9 terabyte per second bandwidth compared to 820 gigabyte per second bandwidth for TRN1. In terms of like the data movement between different chip, so there is like a kind of 3.5 terabyte per second DMA bandwidth for TRN2 compared to 1 terabyte per second DMA bandwidth for TRN1. Also, as I mentioned, in terms of like the connection link, TRN1 were supported by Neuron Link version 2, while TRN2 is supported by Neuron Link version 3. So TRN instances come in also in various sizes to meet different training demand. For extremely large scale training job where individual servers are not enough, AWS deployed TRN instances within the Ultra cluster. So you can imagine an Ultra cluster as a massive interconnected network of TRN servers, all working together to train a single AI model. This is made possible by this elastic fabric adapter, which is a high performance networking technology that enables incredibly fast communication between servers. The scalability of the Ultra cluster is truly remarkable. Each cluster can contain tens or even thousands of Trainium accelerators, creating a pool of computational resources that can tackle the most demanding training tasks. This level of scale is also essential for pushing the boundaries of AI, allowing researchers and also developers to train models that were previously considered impossible due to their sheer size and complexity. Here's also, you can see the specification of both TRN2 instances and also TRN Ultra service. So as you can see, so TRN2 actually instances come in two primary sizes, TRN2 .40x large and also TRN2U .40x large. And also each of these instances, like the TRN instances, as you can see, the architecture include the 16 Trainium 2 chips, which are interconnected by Neural Link version 3. So as you can see, and then in terms of like the topology here, it's just more like a kind of 2D torus topology, which is 4x4. As you can see, the kind of like the topology for these TRN2 instances. But TRN2 Ultra servers, it actually houses 64 Trainium 2 chips connected in a ring topology across the instances, which allow actually just the large scale distributed training with exceptional inter-instance communication. Also in terms of like the memory, so the device memory scales from 1536 gigabyte in TRN2 instances to 6144 gigabyte in Ultra server instances. So as you can see, like in terms of like the bandwidth also, like TRN2 to ultra servers, you can see the kind of like 185.6 terabyte per second compared to 46.4. As you can just like go through and like compare all these specification of these two types of instances. All right. While Trainium hardware is also, you saw like in terms of like the specification and capabilities, which is impressive. The true power is also uh, unleashed through a comprehensive software ecosystem as well. At the core of this ecosystem is the Neuron SDK, which acts as the bridge between Trainium and the world of machine learning frameworks. So developers using popular frameworks such as PyTorch and TensorFlow don't need to learn any new things with the Trainium. So the Neuron SDK handle the complexity of compiling and also optimizing the models for execution on Trainium unique architecture. Also, to further simplify the development process, AWS also has partnered with Hugging Face to create Optimum Neuron, which is a library that makes it incredibly easy to run the Hugging Face model on Trainium. This integration streamlined the workflow for developer using Hugging Face, which is a popular platform for hosting and sharing pre-trained model. The Neuron SDK also includes a suite of tools to help developer monitor and also optimize the model performance on Trainium. Tools like Neuron Top and Neuron Monitor provide real-time insight into how Trainium is being utilized. So, if you remember in previous video, which was we were covering the NVIDIA GPUs, there was like a number of tools provided for profiling and debugging by NVIDIA. So kind of like similar mentality you can see here for Trainium as well. All right, now that we have a good understanding of Trainium and the architecture, now let's talk about the Inferentia. So again, you can see the architecture of both Inferentia and Inferentia 2 here. So as you can see, the version 1 includes 4 NeuronCore, version 1, while the Inferentia 2 just includes 2 NeuronCore. So in terms of like the communication link, so Inferentia version 1 were based on Neuron Link version 1, while Inferentia version 2 were based on the Neuron Link version 2. So now let's also quickly compare the key features of those two types of instances based on Inferentia version 1 and Inferentia version 2. So both Inferentia version, the Inferentia version 1 includes 4 NeuronCore, while Inferentia version 2 includes 2 NeuronCore. In terms of like the device memory, so Inferentia 2 has 32 gigabyte with this 820 gigabyte per second bandwidth, while Inferentia version 1 includes 8 gigabyte device memory with 50 gigabyte per second bandwidth. Also, both, as you can see, in terms of like the Neuron Link, they both leverage Neuron Link version 2. For the EC2 Inf2 instance, which is powered by up to 12 Inferentia 2 chips. So as you can see, like the specification, so we have like a different size of instances: Inf2 X large, 8X large, 24X large, and also 48X large. And as you can see how each of these instances, so as you can see, up to 12 Inferentia chips were used in those types of instances. As you can easily just like there are like up to 192 vCPUs and also 768 gigabyte of memory, and you can just compare the rest of these specifications for Inf2 instances. Again, similar to Trainium, Inferentia is also supported by a robust software ecosystem. So Neuron SDK, which plays a central role providing the tool and libraries to compile and run model on Inferentia. Also, as we mentioned before, so Neuron SDK can support both PyTorch and TensorFlow. So you can just easily just use those model based on these frameworks on Inferentia as well. And also Amazon SageMaker, which is the fully managed machine learning service, also provide extensive support for Inferentia. So SageMaker offers tools and features that streamline the process of deploying and managing inference workload on Inferentia instances. So SageMaker Inference, as an example, so SageMaker Inference Recommender, which is a valuable tool that can help developer optimize their inference pipeline, it actually and provide data-driven recommendation for instance selection. So it actually also support the Inferentia instances as well. In terms of like the application and use cases, so there are like a number of companies that leverage Inferentia for their AI/ML workload. So as an example, Prime Video uses Inferentia to speed up the analysis of live video streams, improve the user experience by reducing delay. So Airbnb also saw a significant performance boost for their support chatbot, making it more responsive and efficient. Also, Amazon.com also use Inferentia and achieve a dramatic reduction in operational costs while also simultaneously improving latency for their inference task. These are just some examples that demonstrate how Inferentia actually can support AI/ML inference jobs for different use cases. All right, I think now we have like a very good understanding of the key characteristics, the architecture of both Inferentia and Trainium. Let's now have like a quick example to just help you how you can just leverage these instances and fine tune and also deploy a model, a large language model on these instances. So there is like a workshop that the link is going to be also in the video's description that you can just use, which is like AWS workshop. So we are going to quickly go through this workshop and some of the code example to help you better understand what are the steps that you need to do in order to just leverage these accelerators for your AI/ML use cases. All right, now let's quickly go through one of the AWS workshop which covers how you can use both AWS Trainium and also Inferentia through Amazon SageMaker to fine-tune a Hugging Face large language model. So as you can see, this workshop, so you need to just go through like there is like a kind of step-by-step process to go through this workshop. So there are like two key sections. One is actually the first section, which is more around how you can leverage AWS Trainium to fine-tune the model. So the model that is used in this workshop is Tiny Llama 1.1 billion. So there is like a kind of for this specific section, there is this code which you can just download it. So I already downloaded here, which is just a notebook that you can just go through that to just fine tune this model. So it's like a notebook, so for sure, like definitely go and check out. But then it's just a very typical SageMaker types of Trainium and also training and fine-tuning job here. So it just you just install the required libraries and also create the SageMaker session. Then you need to use this Neuron deep learning container, and this is the image details for that. And then you just configure this PyTorch estimator. So if you remember, we said that we can easily use Trainium with this popular framework like PyTorch and also TensorFlow. So here you just create that estimator. So if you are familiar with this training models with PyTorch, you should be familiar with this estimator. And then when you create that with just using the fit function, you can start to run your fine-tuning job. And then you can easily just check in terms of like the timing and each batch how it actually just operating, and then put the output and the fine-tuned model artifacts in a like kind of a specific destination. So this is just feel free to go through this notebook, and then you can learn how you can just fine-tune a model using Trainium. So the next section is just cover how you can, when the model is fine-tuned, then how you can just deploy it on Inferentia. And again, there is another notebook for this purpose, which is show you how you can deploy a fine-tuned model on Inferentia 2. And then kind of like similar process, you just initiate the libraries, and then you need to just use the specific kind of container image. And then one thing that you need to consider before you deploy a model, you need to prepare the model for the serving purposes, and you need to just do some level of you need to do some compiling, and then just optimize the model for the inference. And this is like kind of like the way that you can do in SageMaker. And then when the model is compiled and also optimized, then you can just define a SageMaker endpoint and then deploy that model. So like here, as you can see, for the endpoint, we just use these Inf2 X large model instances, and then we just deploy the model and then start to test the model through some kind of like example text to see how it actually just generate the output. So that's a kind of like, feel free to go through this workshop. It actually just gives you a very good understanding of how you can just fine tune the model using these AIML hardware accelerator of AWS. I hope you enjoyed the full kind of video of this, and yeah, that's it. And then stay tuned for more future kind of like videos on leveraging different hardware accelerators for AIML use cases. Thank you.